But end of February, they said they're gonna put more out. They have said they're not taking stuff out.
Well, they did that a while ago. You just did the last few days.
Yeah, I mean, I would know because I'm a part of that group. I'll know like as soon as it would happen. But like I said, they have said it's going to be over everything. I don't see that changing. The only thing I'm curious about is the in-home versus in-school testing, how that's going to work. So I'm under the assumption that everything will be fair game. I'd be shocked if it wasn't, but we'll see. Okay, so like I said, you're hoping that there's going to be a parametric problem because really there are 1, 2, 3, 4 things to know with parametrics, and the calculus within the problems is quite easy. Your calculator will do a lot of the work for you once we get into the actual problems. These are typically calculator active questions. So after I get through the notes, I pulled out an FRQ from 2016. I think that was the last full-blown parametric FRQ that was out there. And so I pulled that one out. I'm going to have you guys work through that. It's calculator active. But like I said, there are just some formulas to know. To remind you guys what a parametric equation is to begin with, because maybe some of you didn't watch that video. I don't know. Did everyone watch the video to remind themselves on parametrics? That's the hope. What a parametric function is, it's basically an x and a y function, but you're in terms of time. So this, with parametric equations, you can say, okay, after 1 second, where are you in the coordinate plane? And you might be at 1, 3. And then you say after 2 seconds, where are you? And you might be at -1, -2 or something. With parametric functions, they're kind of cool because they can look crazy. Like you can have a parametric function where it goes like something like that, and it's still a function. Like for every 1 time, there's 1 place in the coordinate plane that you're at. Even though what you guys have in your mind of what an actual function is, that doesn't surpass it. But for every 1 time, there's 1 output. And so that's just what a parametric function is, or a parametric equation is in general. You can figure out exactly at a time, where are you in the coordinate plane? So that is my brief refresher on parametrics. And now we're going to jump into the calculus. Okay. So parametrics are always defined as 2 separate functions in terms of t to find an x coordinate and a y coordinate. And it's used to describe the path of an object over time. So the first thing we're going to find is dy dx. It's a formula. So the questions are going to say, they're going to say, what's dy dx? Find the slope of a tangent line, or find the equation of a tangent line. Here's your equation for dy dx. The first thing you're going to do is find the derivative of y with respect to t. So you look at your y equation and you just find the derivative of that. And then you're going to divide that by the derivative of x with respect to t. And I'll explain why notationally this is working. So if we're after dy dx and everything's in terms of time here, well, if we treat these like they're fractions, imagine that you're dividing by a fraction, right? If I have 1 fraction divided by another fraction, that would be the same as multiplying by the reciprocal. You don't have to write this, but this is why it's working out. If I divide and multiply by the reciprocal, the dt's cancel, and that's how I get to dy dx. That's why the formula works how it is. So it's super easy to use. You just find the derivative of the y function and divide it by the derivative of the x function, and you have dy dx. Okay? So that was pretty easy. The next one, the second derivative. So here's the second derivative equation. It's the derivative of dy dx with respect to t. So you have to find the first derivative. Then you find the derivative of that. And that's when a lot of students stop. Like you'll have dy dx equals blank, and you find its derivative, and you think you're done. But the tricky part of this one, you then have to divide that by dx dt. This is the part that a lot of students forget. And I've always kind of struggled with kind of the why until, again, I get into the notation of this. And if we're looking for the second derivative, notice there's no t's right here. We're trying to get rid of the t's. Well, if we don't divide by this dx dt, if we don't get rid of it, or if we don't divide by this, we don't get rid of this dt right here. So by dividing by this, if I look at the notation here, again, this is not something you have to know. I'm just trying to explain notationally what's happening. And maybe this will help you remember to divide by dx dt. So if, again, I multiply by the reciprocal of this, I would have the derivative of dy dx over dt, and then times dt over dx. Again, the dt's cancel, and then you can kind of see where this notation comes from. Like you have d dy. This is why this, I've showed this before, but only like one other time. The reason this notation is what it is, like d squared y over dx squared, is because you have d dy, so that's like d squared y, and then on bottom you have dx dx, which is like dx squared. So that's where that notation comes from. But without dividing by that dx dt right here, you would still have dt in your work and you're trying to get it to go away. So these are just two formulas that we have to keep in mind. The speed formula, so just like in first semester, we talked about speed is the absolute value of velocity. Here's the speed formula. I'm not going to get into why it is what it is. On today's Canvas page, I did put a little video on like where it comes from. It comes from like vectors and Pythagorean theorem and stuff with physics. So if you are curious where this formula comes from, I did attach a little video on the page today. But the speed formula is this. It's the square root of, it's going to be dx dt squared plus dy dt squared. It's basically the distance formula. If you would watch that video, it's the distance formula. And then the last formula we have to know, well, if you, again, think back to first semester when you had to find total distance traveled, you integrated speed. You integrated the absolute value of velocity. And that's what happens here. If you're looking for total distance traveled of a parametric equation, which is really asking for arc length, like if this was my path that the thing took and I want to know how far did it go, I'm really just trying to figure out how long is this whole thing. I'm looking for arc length of this. But in general, total distance traveled is the integral of speed. So we're just integrating that speed formula. So these are your formulas that you're going to have to know. If you have these formulas down, parametrics are quite easy and you hope to see them. You really do. And oftentimes they're calculator-based questions. So like a lot of this integration, you won't have to do by hand. You just use your calculator. We'll practice that. In physics, you guys do a lot of vector notation stuff. Is that fair to say you do vectors? We don't in here, but the only time vectors show up is with parametrics. So sometimes, I'll show you this question. So this question on the notes, it says, what is the, so they give the velocity vector, and then it says, what's the acceleration vector? It's basically you finding the derivative of each one, but just having it be in vector notation. So it's not a formula you need to know. It's just when they ask it to be in a vector, then they just want those angled brackets. So if I want the vector notation of velocity, well, it would be the derivative of x, comma, the derivative of y. What's given is position, like x of t and y of t, these are positions. And if I want velocity, we differentiate each one of these, and then we just put it in vector notation. You just put each derivative inside the vector notation. So that one's not really something that is crazy difficult. Pretty much the only thing I find students struggle with is remembering to divide by dx dt for the second derivative. So we're going to dive into the notes, the examples here. It says, let C be the curve with parametrization, x equals t cubed minus 2t and y equals t squared minus 3t plus 4, where t is a real number. I forgot on the notes to put greater than or equal to 0. Almost always. In fact, I don't think I've ever seen a case where it wasn't set greater than or equal to 0 because it's time. So it's never going to be negative. I guess they could say, greater than or equal to 2 or some other positive number, but it's never going to be negative. So t has to be greater than or equal to 0. Find an equation of the tangent line to C at the point corresponding to t equals 2. Okay. So if I want an equation of a tangent line, I need a point and slope. So if we need a point in the coordinate plane, then that means we need to figure out at t equals 2, what's the x coordinate and what's the y coordinate. We have to find the initial point. So I need to find x of 2 and y of 2. So I'm just plugging 2 into the two equations they give. So x of 2 is 8 minus 4, so 4. And y of 2, 4 minus 6 is negative 2, plus 4, that's 2. So my ordered pair is 4, 2. What that means is, imagine, I don't know what t is in, let's say it's seconds. So after 2 seconds, or at 2 seconds, this particle in the coordinate plane is at 4, 2. That's what parametric equations do for us. The last thing I need is dy dx. I got to find the slope. So I got to find dy dt and dx dt and divide them. If I want dy dx, the slope, which is what I'm after, then I have to do dy dt over dx dt. I got to find the derivative of y, which is 2t minus 3. And then the derivative of x, which is 3t squared minus 2. And so dy dx is 2t minus 3 over 3t squared minus 2. I'll stop there and let everyone kind of catch up. I do find a handful of students will flip this and put dx dt on top and dy dt on bottom. And I get why that happens because x is always given before y. So just be careful there. That's something I do find that happens. So now I need the slope. I need to find dy dx when t is 2. So dy dx when t is 2 is, now I'm just plugging 2 into that derivative. So 1/10. And then I write my tangent line. I have the two things I need. I have my point, I have my slope, point slope form. You can graph polar or parametric functions. I've never seen this needed. Like you never need to do it. But I think it's kind of interesting to see. You can see if your slope makes sense, if nothing else. So if, in case you're curious, if you do want to see what the parametric looks like, if you go to mode right here next to second, if you push mode, and then if you look right here where it says function, it says parametric, it says polar, probably sequence is my guess. But if you switch it over to parametric mode, and then you go to y equals, now notice, I was fiddling with this yesterday. Now notice they give you like x1, y1 sub t. So if I wanted to put in this particular problem, I'd put in t cubed minus 2t. Oops. Again, this is not something I think you would ever have to do on an actual AP test. And notice what happens now when you push your variable, it's a t instead. And then t squared minus 3t plus 4. And then graph. And you can see what that parametric function looks like. And so if at t equals 2, where are we? 4, 2. So at 4, 2, 1, 2, 3, 4, 2, we can see our point that we found is on the graph, which it should be. Then we can also see the slope right here is something really, really shallow. And we found that slope to be 1/10, which makes a lot of sense. So you can kind of verify with that if you have time. It's kind of neat. All right. Next one, for what values of t is the tangent line horizontal or vertical? Any guesses? How we figure that out? Yeah.
One of them would probably be 3 seconds,
Why?
because it'll make the top of the derivative 0, which would create a horizontal tangent line.
Yeah. So if they ask for where is there any horizontal tangent line, then we're really being asked when is the derivative equal to 0? So what's really happening is I want to know when will the numerator of dy dx be 0. So when we're asking for horizontal tangent lines, we're setting the numerator of the derivative equal to 0. So 2t minus 3 equals 0. Why'd you say 3 seconds? You said t is 3.
3 seconds.
But why did you say 3?
Three.
Oh,
What do you mean?
I thought you were saying like 3 seconds.
Oh, no, I was actually saying it right. I heard 3. 3 seconds. What do you? Come on now. Did you hear me?
Is that how you say?
I understood what you said. It would be. Okay, you can say 3 halves.
It'd be 3 halves. But I don't think you would say 3 seconds.
I get it.
Yeah, I don't think that's right.
No, it's not. I understood what you say.
Yeah, I took it as him saying like seconds, it's like minutes or whatever. Okay.
Yeah.
Seconds. I know it's halves. I'm just
No.
well, I think all of us do except you. All right, when it's vertical, we're setting our denominator equal to 0. So 3t squared minus 2 equals 0. Okay, I should have labeled that horizontal. Add 2, divide by 3. Technically, you'd have to put plus or minus because it's algebra, but t is greater than or equal to 0. So you can't have negative time. So you wouldn't include the minus part. So really no need. So both pretty close to where it started. And you could see that, again, graphically, right here. You can see the vertical one happens pretty quickly because it starts here at 0, 4. And then the graph went like this. You could see it being graphed. In fact, I think you could set these. I'm not going to mess with this. But I think you could set these to graph slower. Because if you're dealing with a parametric and you kind of want to see, let's say it's really messy looking, you want to see like the path. I think you could set these to graph slower, but regardless. You can see the vertical tangent right here. And then you could see the horizontal tangent right here. All right. I want you guys to try example 2. Try example 2. Por favor. Triple dog dare you. Stick your tongue to that frozen basketball pole.
My dog did that yesterday and his tongue started to work. You opened the freezer, like the bottom freezer, and you licked it and it went to pull away and his tongue started.
Oh no.
Yeah.
Did I tell you guys I did that in kindergarten? I didn't tell you that story.
No.
We had watched A Christmas Story the night before. We were waiting for the bus in the morning, and I wanted to see if it worked. So I went out and I did it, and it sticks. Like I couldn't get my tongue off the pole, and so I'm out there. I tried to tug it off. It hurts. My dad like finally saw me. He thought my brother's 5 years older than me. So he thought my brother told me to do it. So he started cussing out, and my dad never like cussed or anything. He starts cussing out my brother and yelling at him and fills up like a bucket of warm water and like pours it on my tongue. I got to stay home from school that day. Yeah.
I was not confident to do it.
You did? But she's older than you. How'd you guys get it off?
Well, I don't remember because it was when we were little, but we were living in Alaska and My parents.
You guys lived in Alaska?
Yeah. But my parents told me that she just like ripped the cup off.
Oh,
Like, I don't know. Like she just ripped it off.
like you told her to do it? You just told her to do it and she did it?
My sister did it to the hospital, and mom didn't believe her, just ripped it off, and her comes out her bleeding.
That's terrible. Man.
Personally, I saw a movie and decided we fancy.
So this story is even worse. So it was probably in 5th or 6th grade, and I was out sledding with a good friend of mine and his mom, and we were leaving, and we were probably like 5 blocks from their house. We walked there or something, and I dared him to stick his tongue to like a pole on the way out. He did it right away. It got stuck. This is the nasty part. We had no water around us, no way to get his tongue off. So his mom licked, but like his tongue and the pole, like all the way around his tongue, kept licking at it to like warm it up to get it to finally like come off. That's the grossest thing I've ever seen. I felt really bad. It's annoying, but it's not hard, right? I'll put the answer up, but don't peek if you're not done. It's just for if you want to check. You don't need to do quotient rule if that's what you guys were trying to do. Is that the annoying part?
Yeah, why don't you do it?
Because
Oh,
you can move e to the negative t up, and then you have e to the 3t and e to the 1t, so that's e to the 4t. I mean, you could do what you're doing if you're doing the quotient rule. It just seems silly though. Let's. When did you guys move here from Alaska? Hmm. Your parents get mad at you and cuss you out. That's what I'm saying. That's weird that she did it. All right, so you first have to find dy dx, which means find dy dt and dx dt. Don't forget about chain rule. I feel like it's been a while since you've done derivatives. So don't forget about chain rule. Then dy dx, put your dy dt over dx dt. And this is where, yeah, if you know a little bit more, think ahead about exponent rules and things like that, it makes your life a little easier. Did you finish the quotient rule? Yeah, I mean, if it's a free response question, you can leave it unsimplified, so it wouldn't be too bad. Like you wouldn't need to clean stuff up in the end. But if it's multiple choice, then this is probably the multiple choice question or answer right here, would be my guess. I mean, you never know. But the point of this question is, so now when you find the second derivative, look at how easy it would be. It'd be so easy to just find the derivative of this and then think that's your answer and be done. Right? It'd be so easy to say the answer is negative 24 e to the 4t. I got my derivative. I found the second derivative. I'm done. But you have to divide that by dx dt again. Again, if it's free response, you can just leave this answer right here. You don't need to do anything with it. But multiple choice, maybe they move e to the negative t up, and then it becomes e to the 5t. You just never know with those wacky characters what they're going to do. Questions on the second derivative? All right. If you forget to divide by dx dt, I will just cut off the tip of your little pinky. Okay? Okay, yeah. Punishment fits the crime. Justice is served. All right, which of the following gives the length of the path described by the parametric equation? So in other words, total distance traveled. So this is us integrating the speed formula. So we have to remember the speed formula, and then we're putting that inside the integral. So the speed formula, never hurts to write it again. Speed is going to be dx dt squared plus dy dt squared. That is speed. We're trying to find total distance from 0 to pi. So we're going to integrate speed from 0 to pi. So we just have to find dx dt and dy dt and then square those things. So dx dt, let's see, is going to be chain rule. Cosine inside stays the same. So cosine of t cubed, and then times the derivative of the inside, so 3t squared. That's dx dt. Dy dt is easier. So it's e to the 5t and then times 5. And now we just have to square each of those. So be careful with that part. So let's see. If I square dx dt, I would get 9t to the 4th. So that gives me my answer. You know, you can look ahead at the choices. You square this part, you get 9t to the 4th. There's only one of those, but you could double check all the rest. If you square 5e to the 5t, you'd square the 5, so 25. And if you square e to the 5t, remember, just e to the 5t, this is just going back to algebra 1, e to the 5t squared, you would just multiply your powers. And that's why it's e to the 10t. So C. What do you think about parametrics? I think they're pretty easy, as long as you know the formulas. 4. Particles moving in the xy plane, they give a velocity vector. What's the acceleration vector? In other words, all they want you to do is find the derivative of each piece and put it in vector notation.
That's what I thought it was asking.
It is that
That
simple.
seems pretty straightforward.
It is very straightforward. So for the acceleration vector, we are literally just going to differentiate cosine 2t and then e to the 3t. So cosine would be negative sine, inside stays the same, and then times 2. So negative 2 sine 2t, comma, and then 3e to the 3t. I should have put some like natural logs in here or something. We haven't done those in a while. The e to the something t just came up 3 times. That's bad. Wasted opportunity on my part to put another thing to remind you guys on. Oh well.
Oh, that's financial functions. The next problem.
Calculator active though. All right, try this one. And then we'll have a juicy little FRQ to work on. So juicy. Isn't there a rapper like Juicy, Dr. Juicy?
I don't think so.
No? Juice chains?
Here's Juice World.
Juice World.
Juice World?
Chains, it's 2 chains.
Oh, 2 chains,
Two
not
chains,
juice
yeah.
chains.
Isn't there a album from like the 80s called like Juicy J or something?
Juicy J. Not from the 80s. It was like 2000s. He still rap.
Juicy J?
Juicy J. Listen to Neighborhood. A pretty good song.
Juice World sounds like it should be like a little juice restaurant. Yeah. He's got a bunch of songs on the radio right now, though.
I don't know what it is.
Which one?
Lucid Dream.
How's that go? Sing it.
Sing it.
I'm not singing it.
Hum it.
You know, I'll be.
I
fine.
know
It's
the
on
name,
radio.
but I cannot like name the song. I just know I know Lucid Dreams.
Soft.
Yes.
You still want us around 3 decimal places?
Have to, or you don't get the point. But only the final answer to 3 places. Within the work, I would go out to like 6 places. All right, don't peek, don't peek. But if you're done, so don't forget what Math 8 can do for you. Because you're basically finding, in the formula, you're finding dx dt at 2.3, and that's Math 8. If you just do Math 8 with cosine of 2 to the t at 2.3, that finds you x prime of 2.3. Same with y prime of 2.3. That's just Math 8 giving you those numbers, and now you're just plugging those in to the formula. It's just boop, boop, boop.
To differentiate that, it would be 2t over the ln of 2 times negative sine of 2 to the t, right?
I don't know what you said. Which one are you finding the derivative of?
Cosine of 2.
Cosine of
Just
2
wanna
to
make
the
sure I
t?
remember still.
So it would be, so if you did by hand want to find this derivative, it would be, let's see, negative sine of 2 to the t, and then it would be times the derivative of 2 to the t, which would be 2 to the t times natural log of 2.
Oh, it's multiplied?
It's multiply. When you're differentiating, it's multiply. If you're integrating, you divide. You made a mistake. But you shouldn't have been doing that anyway.
Well, I kind of just wanted to decide that doing the calculus would just be so much more fun by hand.
But then you're gonna have to use the calculator anyway.
I kind of forgot.
Remember, the final answer should always be to at least 3 places. They've said once you put the 3rd decimal, they won't read past that. Like you could put 1, 2, 3, 4, 5, 6, 7, 8, 9 after that, and it can be wrong, and they don't even look. Don't test that theory, but go to 3 places. Within the work, though, like I was saying, don't round these to 3 places. You might be off by 1,000th or something. I don't know. I didn't do the calculation, but you could be off by 1,000th if you round these. Anybody do it? Curious now. So if I do square root of, and if I round those to 3 decimals, 3.33, say I truncate 6 squared plus 0.718 squared, I would get, yeah, I'd be off by 1,000th. I would get 3.412. And the answer is 3.413. Unless, so I don't know what this actual answer turned out to be. Was it 412 something? Did I round up? I don't know. Then yeah, you'd be wrong. So, point, Giordano. All right. So we are going to try one FRQ. Again, this was the most recent parametric FRQ that was out there. You want the parametric FRQ, but like I said, the previous 4 years have been polars.
Maybe we'll switch it up.
Maybe. I hope.
Time for kids.
I hope.
Maybe they're handing out BC calculus this year.
It seemed like they, to be honest, it seemed like they kind of handed out BC credit last year because like they took out 3 units of physics. They took out a lot of the BC content last year that wasn't on the test. I was surprised, but I think I had 2 people get 3s last year. All right, so I want you guys to work on this. I'm going to give you guys, yeah, time. Give you like 14 minutes. It's calculator active. I posted it on Canvas too, I believe, if you want to pull it up and you can work on there. But I have it here. If you're watching this video later, you could pause it now, work out this problem, and then fast forward through the video and see my explanation.
Yeah, Braden.
But just in the future. It's nice having these videos, then I don't need to make like lesson videos on my own. If I would miss a day, like here. All right, so I'm gonna put you on the clock. I'm gonna give you guys 14 minutes. Ready, set, snow. Like 3 minutes. You finished? You get a 9? Well, you get a 9? 9 out of 9?
Maybe, I don't know.
You don't know?
I utilized the calculator this time.
Well, that's good, because I think you had to use the calculator on at least A. Did you have to on C? Could have left your answer very, very gross on C. I don't think calculator would be necessary. D, you would. B. B, you wouldn't. You guys ready? Finish? You guys finish? Finish? All right. So let's take a look at the rubric here. Very first one, when you're finding the position, okay. So the y one is very easy because they give you the graph of y, so you're just looking for y of, what is it? 3. For x though, be careful. This is that whole, you're looking for the final value, the starting value, and then you need to figure out how much it changed. And we did a bunch of these first semester, but it's been a while. So if you're looking for x of 3, x of 0, find the change in x from 0 to 3. So integrate x prime. This is where you have to use your calculator. But I can see if people forgot about the 5 right there. And so there's your position, 14.377, comma negative 0.5. For B, this is just your y prime of 3 over x prime of 3. Y prime of 3 is the slope of that graph. And then x prime of 3 is math 8, unless you try to do it by hand. Oh no, you wouldn't even need math 8 because they give dx dt. You would just have to plug 3 in to this right here. Just plug 3 into this.
I differentiated that again.
By hand?
No, like on the calculator, I wasn't thinking that was the actual.
Yeah. Yeah, that's why it's creative because they give you y and then they give you dx dt. Very creative question. You guys kind of switch your thinking. C is like that last problem we did in the notes. And then D, you're just integrating the speed. They went from 0 to 1. They split it 0 to 1 and then 1 to 2. Is that because y changed? Yeah. So like I said, the hope is that you're going to see either a parametric or a polar. Almost guaranteed. I can't say 100%, but that's how it's been for the last 10 years. You hope it's parametric because you should probably at least get 5. I would think on a parametric. Polar, they can just get pretty crazy. Not even impossible. They're just tougher. Anybody get a 9? No? What was causing the issues?
We differentiated every time again.
I messed up on the first one, and it's just.
The first one was only one I got both of them. For B through D, I did the right process. I just differentiated t squared plus sine of 3t squared, just relative opinion. Because I thought it was just x, even though it's the derivative, so you don't have to do anything to it.
Word. Any questions on parametrics? You guys at home? Any questions on parametrics? All right. The next time we'll have a little 4-question quiz and then talk about polars. So, all right. You guys are free to go. Peace, you have like 5 questions for homework or 7 or something. I forget what I said.
Now stop the recording. I think I'll do that.